we have y equals to x squared, x is equal to 1, y is equal to 0, and you want to rotate this region about x equals to 2, negative 2, and you want to calculate the volume. So let us visualize this guy. What are we dealing with? Here you have y equals to x squared, quadratic function, x is equal to 1, and then you have y equal to 0, which is basically your x-axis. And you want to rotate this about x equals to negative 2. The line x equals to negative 2 is just right on the other side. So x equals to negative 2. Okay, after we do the rotation, this is what we're seeing. We're taking this region, and here we have this. So, okay. When you're doing the rotation, you have 1 unit here and you have 2 units here. So you're going to get 3 units over here. 3 units further, right? And this is your x squared, and this is your region. And here you had the rotation. So we're using this dotted line to show that, hey, we actually did the rotation. So what's the cross section here? Which method you prefer to apply here? Since this guy is parallel to y-axis, parallel to y-axis, if you decide to use the washer method, then you have to write everything in terms of y. But let us apply the shell method, right? Why not? In applying the shell method, if you look at a typical cylinder, with base here and the height, as it is changing. My cylinder is not very accurate, but I want you to get the general idea of what's going on for our cylinder. So the cylinder has a base which is located on x-axis, but the center is not exactly at 0. The center is shifted to negative 2, right? So if I ask you to find the circumference of the base, which is 2 pi r, what is that radius? The radius is not exactly centered at the origin. We shifted that 2 units to the left-hand side. So the circumference is 2 pi times x minus 2, or 2 pi x plus 2. This is the radius that you're having. So in applying the shell method, the volume is equal to the definite integral of 2 pi r, which is 2 pi times x plus 2, times the height. Well, calculating the height should be very easy for you by now. The height of this typical cylinder is located here. This is your height. From top, it's bounded by x squared, right? So the height is x squared minus 0, or just x squared, and then dx. But what are the boundaries, right? So the height is x squared minus 0. What are the boundaries here? How do we calculate the boundaries? How our x is changing? Just look at the graph. Here, the origin, x starts at the origin, and the maximum value it takes is 1. So your x is bounded between 0 and 1. Okay, perfect. The rest is just applying what we learned in calculus and doing algebra. The volume is 2 pi. The integral, distribute x squared into parentheses, get x cubed plus 2x squared dx, and the volume becomes 2 pi 1/4 x to the 4th plus 2/3 x cubed. X ranges between 0 to 1. So volume is 2 pi times 1/4 plus 2/3, or the volume becomes 2 pi. If you take common denominator 12, you get 3 plus 8, or the volume is 22 pi divided by, we can simplify this, 22 pi divided by 12, or 11 pi over 6. So this is the volume that we can calculate using the shell method. If you were to use the washer method, that's a different story, right? You have to write everything in terms of the other variable, in terms of y. Because your cross section has a radius which depends on your y. So it should be written as x equals to square root of y, and then use that as the radius to the second power. But the volume must be the same. At the end, when you do the calculation, you must get 11 pi over 6.